So this is a brief introduction to EViews. You can download as a student, you can download a free student lite version. If you go to eviews.com and then products, student version. There's a student version and a student version lite, which is free. Just click on the free download and you get a license key and a link to a site where you can download EViews. So once installed, it looks like this. You have an area at the top here where you can type in commands, and you have the big area below where you have all your data and results. You can import data from many sources, for example Excel. And to do that, you basically have two options. You can either just take your Excel file and drag it into this area, or you can go with File, Open, or you can import data. You can of course also export your data. So once you have your data in EViews, just drop it like this. Well, first you can control also more of the details in terms of what data to import. So I'm going to import this data set, which consists of 9 students with the number of hours they've studied for a course and the result on the exam. You have the options to set the name of the variables. EViews will by default pick the name in the heading as the name of the variable. And you can tell EViews if you have some particular structure in your data, for example, if you have panel data or if it's time series. In our case, we don't need to make any changes, so just finish. We can ignore that, and then you have your data. EViews works with data in what it calls work files. Work file contains the data that you import, but also any kind of work that you do with this data. For example, fitting a trend line or whatever you do. You can see that EViews has added actually 2 variables to our set that we didn't include. We provided the X, which was number of hours studied. We provided Y, which was the result. And we also had this observation, which was just a count from 1 to 9. It has provided something it calls a C. C is a constant. We'll see later the role of that one. And it has provided resid, which is short for residuals, which is initially just empty. So if you want to have a look at your data variable by variable, you can just double click on it. So here's my X data, the number of hours that my 9 students studied for the exam. You have options to work with this particular data. You can create a graph of the data. You can do descriptive statistics. So here you find the mean, the sample mean, the maximum value, the minimum value, and so on. Sample standard deviation. You can also open 2 variables as a group by just clicking on both of them. Well, you need to click first one of them and then hold down Control key and click the other one. Now you can open that as a group by double clicking this, open group. That allows you to do, for example, you can do the covariance between X and Y. You can make a scatter plot of X and Y. X, Y, scatter. which will give you a picture similar to the ones that we have in Excel, um, just the blue dots then. So the last thing I'll cover in this introductory EViews lecture, we can delete this group, is the OLAS regression, and that is fitting a linear trend line to the scatter plot. To do that, you go to Quick, Estimate Equation. By the way, you always have two options to analyze data in EViews. One option is to go through the menu system the way I'm doing it right now. And the alternative is to type commands into the command window. I think typically as a beginner it's probably easier to go with the menu system, but then when you get more used to EViews, it's typically easier to just type commands. It's usually quicker. So here we need to specify the equation of our linear trend line, and we then just simply start with the dependent variable. We want to explain y, the result on the exam. We want to explain that with x. That's our explanatory variable, but we want to include an intercept. And the way you tell EViews that you want to have an intercept, or an intercept different from 0, is you put a c after that. So y, c, intercept, and then x. And that's really all you need to do to get your linear trend line. If you want to, you can also use the notation following this example above right here. So as an alternative, you can also write y is equal to, and then c of 1, which means the first constant, plus c of 2, second constant, which is the slope, and then a multiplication sign and an x. So you can also do this. It's quicker, of course, just to do ycx, and the result will be completely the same. You can see that EViews has the default method, the least squares method. So it will indeed minimize the RSS. So it'll give us the OLS estimate. So here is the result. And here I have pulled this into OneNote. So you have some information, the name of the variable that you're explaining, the method that we have used to find these numbers, the least squares method, the sample from 1 to 9, total of 9 observations, this first number, the coefficient after C, that's the intercept of the linear trend line, and this is the slope. And if we compare these two numbers to what we got in Excel, minus 8.33 and 0.6, we can see that they are indeed the same. Two more values I want to point out from this printout. One is the r squared that you can find here. Remember, r squared is the explained sum of squares divided by the total sum of squares. The measure of fit, we did that also in an earlier lecture, and we got r squared here to the same number. We have here the sum of square residuals, so that's our RSS. And just to compare that as well, 159.28, we got the same value right there. Well, actually, there are two more numbers that we can point out also right now. That's the sample mean of the dependent variable. So that would just be the average of this guy, 72.33, and the standard deviation of the dependent variable. That we can check as well. That would just be STD sample standard deviation of the dependent variable. So that comes out to be 15.19, which is what we got here as well. The other information from this printout will be covered in later lectures.